Welcome to Everyday Mathematics. Today we look at problem 21 of the MIT Integration B 2011 qualifying exams, which is the definite integral from x equals to 0 to x equals to 6 of the square root of 6x minus x squared. I'm sure there are many ways to look at this problem. I will look at one of them, and hopefully that will be interesting to you. Our problem is the definite integral from x equals to 0 to x equals to 6 of the square root of 6x minus x squared. So one of the ways I think we can solve this is by pulling one x out, so that you do have 6 minus x dx. And then we could say let y be equal to the square root of 6 minus x, such that y squared equals to 6 minus x. And so when you differentiate both sides with respect to x, we have 2y dy dx equals to negative 1. And so negative 2y dy could be substituted for dx. So this is one important variable, one important substitution. And then now we can look at the limits. X, y. When x equals to 0, looking at this, we have square root of 6. When x equals to 6, we have 0. So in other words, our integral, that is from 0 to 6 of the square root of x times the square root of 6 minus x dx would be equal to, we saw with respect to 0, we saw that that corresponds to root 6 in the y domain. At this point here we have 0, and then square root of x is the same as square root of 6 minus y squared, and this part here is simply y, and the dx here is negative 2y dy. So that we have now this negative here causes us to swap these limits. So we have root 6 at the top, and the 2 comes out, this 2 here. So we have square root of 6 minus y squared, this y, and this y dy. So now things are more interesting here. So I could easily say let y be equal to, because I want to put in a trigonometric function that will allow me to factor the 6 away. So I could say root 6 sine theta, such that dy d theta is equals to root 6 cos of theta, and that's dy is equals to root 6 cos theta d theta. Now, since we said y is equals to root 6 sine theta, that means that in y and theta domain, when y is 0, that means 0 divided by root 6 is 0, arc sine of 0 is 0. When y is root 6 at the upper limit, root 6 divided by root 6 is 1, so arc sine of 1 is pi over 2. Therefore, what we have here now is the integral from 0 to root 6 of 6 minus y squared is the same as twice 0 to pi over 2 square root of 6 minus 6 sine squared sine squared, and then dy becomes root 6 cos theta d theta. So oh sorry, we have another 6 here. Okay, so this becomes 2 0 pi over 2. Pull the root 6 out, so we have square root of 6, 1 minus sine squared theta, okay, sine squared theta, another root 6, and then cos theta d theta. Okay, so this and this can be bunched together into a 6. We have a 6 here. So we have 6 times 6, 36 times 2. We're going to have 72, right? So we get 72 out, 0 pi over 2. And since we had 1 minus sine squared theta square root, that becomes cosine theta times sine squared theta times cosine theta. And so this becomes 72, 0 pi over 2 cos squared theta sine squared theta d theta. And this becomes 72 divided by 4 is 18. Why? Because this becomes a 4, and 4 times 18 is 72. So this becomes 18, 0 pi over 2. 2 sine theta cos theta is sine 2 theta. Okay, so this becomes 18, 0 to pi over 2 sine squared 2 theta with theta. Now we know that cosine of 4 theta would be equal to 1 minus 2 sine squared 2 theta, such that sine squared 2 theta is equals to 1 minus cosine 4 theta divided by 2, right? So in other words, our problem becomes 18, 0 pi over 2, 1 divided by 2, 1 minus cosine 4 theta. Okay, and as we continue, since we do have a 9, 0 pi over 2, 1 minus cosine 4 theta, this becomes 9 theta minus 1 over 4 sine 4 theta, 0 pi over 2. Okay, so I will see very quickly that this goes to 0 at both the upper and lower limits, so we have 9 pi over 2 minus 0, which is equals to 9 over 2 pi. And that is our answer. So I hope you had some fun following along. Certainly an interesting problem. But if you have any questions in that regard, please feel free to reach out to us. We'll be very much willing to chat with you about it. It was great hanging out with you. Until next time, atutaluk, ala prochaine fois.